A couple of years ago, Works by Design made this video, and I've kind of been thinking about it ever since. He built a high-torque bicycle with pedals that travel vertically up and down, rather than in a circle. It uses this huge cylinder in the middle of the frame to translate a linear pedaling force into rotational motion, which is really cool, but also pretty complicated and bulky. So I couldn't help thinking, surely there's a better way, or at least a more compact way, and if there is, can I build it? My idea is to take a normal set of pedals connected by a crank, and get rid of the crank. Then I connect the pedals by a belt instead. If I drape this belt over a sprocket, it will convert our vertical motion at the pedals into rotational motion. With just one catch. With each stroke of the pedal, the direction of the sprocket reverses. So we need to attach our sprocket to some sort of mechanism that takes in rotation in any direction, and outputs rotation in just one direction. So I built this. It's a proof of concept with an input shaft and an output shaft. No matter which way you turn the input shaft, the output shaft always turns the same way, although you can't really tell, because I printed everything in matte black, with no markers, so you're just going to have to trust me on this. Here's how it works. First you need some way of separating the clockwise and anti-clockwise rotation on the input shaft. So we add two gears to the shaft with freewheel mechanisms, and make sure the freewheel mechanisms work in different directions. We'll call these gear A and B. Now, when the shaft turns one way, gear A transmits the rotation, while gear B freewheels. And when the shaft rotates the other way, rotation is transmitted through gear B, while gear A freewheels. Now we can turn these gears into bevel gears and connect them both to another bevel gear at 90 degrees to the shaft. This gear will only ever spin in one direction. If you don't understand why that's the case, bear with me a minute. I'll be honest, I was pretty pleased with myself when I came up with this, but within a couple of weeks of finally working it out, I sat down to mainline some YouTube and came across a video from Maker's Muse, in which he built the exact same mechanism after finding it in a book from 1868. Thankfully, his explanation of how the mechanism works was much better than mine, so I've left a link to his video in the description if you didn't follow my explanation. As far as I can tell, despite being over 150 years old, this mechanism doesn't have a name, so for the rest of the video I'm going to call it a mechanical rectifier, or just a rectifier. I'm going with this because rectifiers in electronics convert alternating current to direct current, which is analogous to what we're doing here, but with rotation instead of current. One more thing to note is instead of using conventional freewheels, I'm using these. They're called sprag clutches, which are a kind of bearing with these weirdly shaped sprags instead of ball bearings. The shape of the sprag means that when you rotate the bearing one way, the sprags just slip, but when you go the other way, they jam the bearing up and lock it together with friction. So now I need a way to mount this whole assembly to my bike, which meant making a 3D model of at least part of the frame. The seat tube on my bike is just a tube, so I could just measure its diameter with calipers, but the down tube has this weird geometry. I only need to know the radius of the top surface, so I literally eyeballed its height and width, then plugged those numbers into this arc radius calculator and got back 30mm, which is a number I didn't trust, so I 3D printed a shim with a 30mm radius and checked it against the real thing, and it turned out to be correct. Then I took a photo of the bike with a pair of calipers sticking out of the seat. Because I'd opened the calipers to a known distance, I was then able to import the photo into Fusion and derive the distance and angles of everything else. That was enough information to make this model of the frame, which I used to design and print brackets that screwed into the frame's braze-ons. And after some trial and error, oh no, I was able to get the mechanical rectifier mounted. Now I need a way of attaching the pedals to the input shaft, so I bought the cheapest belt I could find, which was too small. So I bought the second cheapest belt I could find, which looked like a fan belt that had been festering in someone's garage for a decade. Probably because it was. But it seemed like the right size, so I cut it and measured the geometry and modelled pedals that clamp onto either end of the belt. My bike has a belt instead of a chain, so I took some measurements of this and after a billion prototypes modelled this sprocket bevel gear chimera. Then I used this to connect the bike's belt drive straight to the new drivetrain's output. And I think it's pretty neat that the fact the rectifier just happens to translate the rotation by 90 degrees means we end up with the output shaft in the right place to just directly mount the belt drive to it. The only thing left to do now was find a way of securing all the rotating parts to the input shaft so they don't just spin freely. I tried a few dumb solutions, like this one that uses a set screw, and this one that uses a split collar, until I finally decided to just pump a ton of epoxy into a hollow hub. So I roughed up the shaft with sandpaper, then I set everything in a 3D printed jig. I mixed 2-part epoxy in a syringe and injected it into the hubs through the thickest gauge needles I could find. This whole process was terrible. It was almost impossible to force the epoxy through the needle, and doing so absolutely destroyed my hands. And when I was done, and after a 24-hour cure, I realised I'd get to do it all over again, since I had no way of getting this sprag clutch over this bearing, so the whole part was useless. So I went through the whole ordeal again, and the second attempt did at least feel more solid. I have finally assembled everything and gave it a quick test in the kitchen. Everything seemed to work, so I secured the pedal belt in place with this incredibly flimsy belt guard. And since it all worked in theory, I was ready to give it a proper test. But in practice, when I tried actually riding the bike, the pedals really sucked. It was almost impossible to get my feet onto them and have them not slip off. So after managing just one pedal stroke, I printed these stirrups that enclosed my feet from both sides. Now with my feet kept in place, I tore the top straight off the flimsy belt guard, which meant the pedal belt immediately popped off its sprocket. So I reprinted the guard with a much stronger top and immediately broke it at the bottom, which for some reason I'd not bothered to reinforce at all. So this time I beefed up the whole belt guard and tried again. I'm pretty pleased I was able to crawl forward slightly here, but I did destroy the whole drivetrain. I'm pretty sure the catastrophic failure was caused by the front bracket for the input shaft shearing apart at the layer lines. Once that happened, the pedal force yanked the drive shafts to one side and basically broke everything else. I think this happened because I printed everything with a 2-layer wall thickness, so I was kind of asking for this to happen. This was fine though, I could just reprint the parts with less dumb settings. More concerning to me is the drive shaft. The epoxy in the hubs has kind of turned to mush and pulled them off centre, and I just don't think this is going to work for another test ride. So I finally bit the bullet and ordered some aluminium stock for the lathe I don't own. And not owning a lathe turned out to be a problem because 15mm stock doesn't fit in 15mm bearings, at least not without some turning down. I began sanding the shaft down by hand, but I decided this was beneath my dignity, so I printed a jig that would fit the shaft into my drill, then I hot glued the shaft in place, and now I was in business. After this, I nearly succumbed to exertion, sawing the shaft to size with this Fisher-Price saw. I know it looks like I could have made this easier for myself by securing the work to my kitchen table properly, but I eventually did do that, and it still sucked. Once that ordeal was over, I printed a drill guide, and drilled a few holes in the shaft. Then I chamfered the holes off with a bigger drill bit, and printed new hubs that secure with bolts instead of resin. I also bought these U-bolts and then redesigned the bottom bracket to attach to the seat tube with them, which should be stronger than just screwing into the braze-ons. And now I've kind of run out of ways I can think of to make this drivetrain stronger, so let's see how it fares. Yeah, it broke instantly, and in a way that surprised me. It should have been obvious, but the forces on the output gear pushing it away from the bike are way stronger than I expected, so the bracket holding it just sheared at the layer lines. I didn't know what to do about this, and to be honest, I felt pretty demotivated by the whole project at this point, so I went on holiday. And came back with a plan to put the part on a PED program. In previous versions, I'd mounted the output shaft on this bearing, which I'd embedded in the print by pausing the print and immuring the part in plastic. The downside of this is that it forced me to orient the print so that the layer lines were at 90 degrees to the direction of load on the bearing, and because 3D prints are much weaker in that axis, the part broke. So I redesigned the part into two chunkier parts and bolted them together with bolts that looked like they meant business. This was a 7-hour print and I fucked up the design the first time, so I had to do it twice, but eventually I got the whole thing reassembled, and this is the result. Yeah, I'm declaring victory here. The bike isn't the easiest thing to ride or the most efficient, it's certainly not durable, it's not lightweight, and it's not cheap. But it does prove my drivetrain works. I'd love to show you more footage of it working, but I took it out for a second ride the next day and broke it in several places. And I think it's probably more worthwhile moving on to a version 2 design rather than fixing this one. I've got a few ideas for a version 2, and one day I'd like to build a folding bike around this kind of drivetrain, because I think the form factor could make some really interesting packaging possible. I'll definitely post videos about these projects if I can get them working, so subscribe if you want to see that. Thanks for watching.